class, in this next section, 2.5, we're going to start to look at some postulates and proofs. So a postulate is a statement that we accept. So I'll just write a statement accepted without proof. And I'm going to read through some of these postulates with you. They're all in your book on page 127. You don't need to know which one is 2.1 or 2.2, but you do need to know just kind of what they say. And a lot of these are things that we've done before. So looking at 2.1, it says through any 2 points, there's exactly one line. So if you want to summarize, maybe write down like 2 points, there's one line. As long as you know that and can use that, you'll be okay. If you want to draw a picture, you would start with those 2 points and then draw the one line that goes through those 2 points and make those points a little bigger so those are actually on there. The next one, we've talked about this in chapter 1 too. If you have 3 non-collinear points, you have one plane. And if you want to draw a picture of that, you could draw 3 points that are not in the same line and then draw the plane that would be around them. For 2.3, it says a line contains at least 2 points. That's basically the same as 2.1, except the converse of it. So this would say you have the one line first, and then you have at least 2 points. And 2.4 is almost the same as 2.2, except the converse of that one also. So this one would start you out with one plane, and then say you have 3 non-collinear points. And like I said once already, you won't be expected to know which one's 2.1 and which one's 2.2. You can use those numbers, though, just kind of like as a cheat sheet for some of the questions we're going to be answering. But you don't need to memorize like which one's the third one and which one's the fourth one. You just need to know kind of what they say. For 2.5, this is something new, but I think you'll get it right away. It says if 2 points lie in a plane, I'm going to write it over here now. You have 2 points in a plane. And probably the picture would be more helpful. So if these 2 points are in this plane, where is the line that contains those points? Well, if I draw the line that contains those points, make them bigger, that line would also be in the plane. So the line containing them is in the plane. There's no place else it's going to be. It's going to have to be in that plane. Remember, postulates are statements we accept without any proof. But hopefully these just kind of make a lot of sense to you. The last two just talk about the intersections. So when you have 2 lines that intersect, where do those 2 lines intersect? Well, when they do intersect, they intersect at exactly 1 point. So 2 lines intersect at a point. And then the next one, we have 2 planes that intersect. This one's a little harder to draw the picture if you want to like copy it out of your book. But when those 2 planes intersect, they intersect at 1 line. And again, we have learned most of this stuff. Now we're just saying, okay, these are accepted truths in the geometry that we're studying. These are things that we're going to accept without actually having written out formal proof for. And you'll see some things as we keep going throughout chapter 2 that we are going to have some written out. This is how the majority of these questions in this section will look. They will give you a picture, and they're going to ask you to identify which postulate this is an example of. If you would like to use the numbers for these, that'll be okay with me. But you can just use them kind of like matching with that chart in your book or with your notes. So for this first one here, it says that we have these points, and these points, A, B, C, or just A, B, C, determine a plane. So if you want to go over here, I know it's kind of hard to see in this picture, but here's B, here's A, and here's C. Which postulate would tell you that 3 points can determine a plane? And again, you can just kind of use this as matching, but the one that says 3 points that are not on the straight line determine exactly one plane, that's 2.2. So that would be all I expect you to do to answer this question if this were one out of the book. Okay, the next one says that planes P and Q intersect in line M. So if you want to find those here, actually these are really hard to see in this picture, so you probably don't need to find them here in the picture. The book's going to give you pictures though to go off of. This is out of your book. But you don't need that for this because the postulate that says that you have 2 planes and they intersect to form a line was that last one. So that's 2-7. And that's the way the majority of these questions are going to look. Hopefully this is a pretty easy section for you. The only thing that sometimes you have to pay attention to is like what part they say first and then what the conclusion is, because 2-1 and 2-4 look very similar other than the fact that the order changes. Okay, a couple more vocab pieces. The next thing will be a proof. And a proof is a logical argument. Sometimes the pen doesn't work right away. That's kind of obnoxious. So it's a logical argument where we are giving supporting statements to prove something is true. So I'll just say to prove something true. And they could be different definitions that we have. They could be, here I'll write some things off to the side. They could be definitions, like we know like the definition of what perpendicular means or the definition of what congruent means. They could be different postulates, like the 7 things that we just learned. They could be different properties. Or they could be different theorems, and we don't know any theorems yet. Well, maybe you do. You know the Pythagorean theorem. But we haven't learned any that are unique to just geometry until now. We'll learn the first one today. So a theorem is a statement that can be proven. So unlike a postulate that we just accept without proof, a theorem you can prove. And I'll show you one of those in just a second. The last piece of vocabulary would be what a paragraph proof is. A paragraph proof is kind of what it sounds like. It's where you write out an explanation for why something is true. So you're going to kind of write a paragraph to prove it. Write an explanation for why something is true. And it doesn't need to be a full paragraph. I know sometimes your English teacher says a paragraph has to be this many sentences and whatever. I'm just going to say as long as you're writing out your explanation, you'll be okay. So I am going to kind of talk you through a paragraph proof for this here. This would be like what you would be writing down. I don't want you to feel like you need to copy all of this stuff down word for word. It'd be kind of a lot to write. But I'm going to kind of talk you through a paragraph proof for if we're given that M is the midpoint of XY, how we know for certain, oh, that shouldn't be there, that XM is congruent to MY. So looking at this, that word midpoint, by definition, means that it splits the segment into 2 equal segments. So the definition of what midpoint means is it would say that XM is equal to MY. And then I would think about what that word equal or what that word congruent means. Well, congruent segments means that they're equal, correct? So if by definition of the word midpoint, we can say that those segments are equal to each other, and by the definition of what congruent means, that also means that they're equal, well, then I'd be able to say that I can conclude that XM is congruent to MY. And that's actually the first theorem that this book introduces. It's called the midpoint theorem. And the midpoint theorem simply says basically that same thing. So it would say that if M is the midpoint of a different segment, let's just call it AB, then you can say that the midpoint theorem would say that AM is congruent to MB. And you guys have known this. We've worked with this. We've done examples of this. But now we're just giving it a name. So whenever you see something like this, you can just say, oh, I know that that is the midpoint theorem.